Hey everybody. So it's Sunday and I'm grading your quizzes, and I noticed that there was a pretty common mistake on the first problem. And I talked about this a lot in office hours last week, but I figured we'd take a moment, go over it real quick. Also, so I can just practice doing this. I want to crack up. I can't believe I'm doing a YouTube live, but came up in office hours last week that it would be good if I did this sort of thing. So what we want to figure out here is how acidic behavior and basic behavior plays a role in our solids and whether our solids dissolve or not. This is on my homework. This is homework 2, problem 10. And specifically, we want to see how a decrease in pH affects the solubility, whether it increases the solubility or decreases the solubility. And it particularly asks you to do this with 2 equations. So again, the first thing we have to do in all of our problems is we want to start by thinking about what do the words tell us to do in the problem. And what I want you to notice is that the reason it has us do this in 2 separate equations is because we have 2 separate concepts we're thinking about. We're thinking about the solubility and we're thinking about a decrease in pH. And for that reason, it makes sense that we would do this in terms of 2 chemical reactions. So if we're going to start by looking at case A, silver chloride, how does decrease in pH or adding acid affect the solubility? We're first going to start thinking about the solubility. So we're going to write down a solubility reaction. That is our solid breaking apart into ions. And we say, okay, great, this is how a solid breaks apart. What happens if we decrease the pH? That is to say, what happens if there's some extra H plus around while this solubility reaction is going on? And essentially, that allows us to think about how would H plus interact with Ag plus and how would H plus interact with Cl minus. Clearly, H plus isn't going to interact with Ag plus because we've got a positive and a positive. They're both cations. So we're going to look at the interaction of H plus with the anion Cl minus. We can say, okay, hypothetically, if this reaction were to happen, I would form HCl. However, we know that this is a strong acid, which means its equilibrium is going to be completely towards, you can imagine writing it like this even. Just a little bit. The equilibrium of the acid reaction is going to be completely towards leaving the H plus in solution and the Cl minus in solution. That essentially means our Cl minus has no change. If we've got no change in the Cl minus, nothing is happening to our first reaction. Nothing is changing in our solubility reaction. So we can see in this case, when we've got AgCl, a decrease in pH has no impact, has no effect on the solubility. Let's do the same type of logic now with another case, and then we'll see that there's an actual trend we can get. If you go through the homework and you do all 12 of these, it goes A through G, that's not 12. If you go through all of them, you're supposed to develop this trend on your own. You can also just read it in the textbook. You could have Googled it. But the idea is that through practice and by doing this type of logic, you actually get to develop the rule, the guideline that we have for this. We're going to do the same practice, though. We're going to look at our solubility, and then we're going to look at a decrease in pH. So we've got SrCO3, strontium carbonate. This is an insoluble solid, but so is silver chloride. We're looking at the slightly soluble phenomena. So we just get a little bit of Sr2 plus, and we get a little bit of CO3 2 minus in solution for our solubility. After this happens, we say, okay, what happens when we add H plus to this, when we have some acidic conditions, a decrease in pH? Two minus on the carbonate, 1 minus on the bicarbonate. And this was one thing that a lot of you asked about, or that came up really regularly. When we're talking about acid-base behavior, especially at this point when we're really focusing on it, we're almost always going to interact one proton at a time, looking at our Ka2 versus our Ka1. So we're just adding one proton in this case. What happens if one H plus interacts with the CO3? We're not going to worry about the equilibrium of a second H plus. In this case, we say, look, we've developed hydrogen carbonate. The monoproduct form of carbonic acid, this is a weak acid. This means some of the equilibrium is going to lie over towards this side. This is going to cause a decrease in our carbonate concentration in our precipitation reaction, or solubility reaction, rather. In this case, when we see this decrease in our carbonate, we're going to see that through Le Chatelier's principle, the strontium carbonate needs to redissolve. Essentially, in this second case, when we have a weak acid being formed, we're going to see a pH change affect our solubility. And after we do this a couple more times, we start to realize if we ever have the conjugate base of a strong acid, nothing happens. If we ever have the conjugate base of a weak acid, something does happen. And that's the kind of thing we want to be looking for when we get the practice, when we get the concept that leads us to this kind of thinking. Then we can start to make sense of the guideline that we have for this. And the guideline is essentially, if the anion of our solid is the conjugate base of a strong acid, nothing happens. If the anion of our solid is the conjugate base of a weak acid, decreasing the pH impacts the solubility. Particularly, it increases the solubility. 10 more for you to do. Keep doing them. You can essentially look at that list of precipitates that we've been dealing with for the last 3 weeks, and you can figure out for each one, is there an impact on the solubility? Bring those questions to me in office hours on Monday, and we'll talk about it then. So it'll be okay. Thanks.